So today we are going to start section 5. We won't finish it in class today. I'll finish it up on Monday. But today we're going to start talking about complex numbers, or in some textbooks they might refer to them as imaginary numbers. So there's two facts that you need to memorize, and they're listed here at the beginning. And you need to memorize that the value of I is equal to the square root of -1. And you also need to memorize that I squared equals -1. So you're going to memorize these because we're going to be using this information. Now, when we add and subtract or multiply, all we're going to do is treat I like a variable. And then when our answer, though, includes, and this I2 here, this is supposed to be representing I squared. So whenever we end up with an I squared in our answer, we're going to take out that I squared and we're going to replace it with a -1. Now, the format for writing answers that have both an imaginary and a real part is this, where A is going to represent the real part of the answer, and the BI is going to be the imaginary part. Now, the imaginary part is when I try to square root a negative number. So this is actually what I'm going to teach you on Monday, is if I give you a number that's underneath a square root, and if it's a negative number, then what I need to do here is you can sort of do like a factor tree. But all I really need to do is do 4 times -1. Because I told you over here to memorize that the square root of -1 is I, and you already should realize that the square root of 4 is 2. So now when I square root a negative number, an I is going to come out of that square root symbol. And then you would do the positive part of the problem just like normal. So for example, on this one down here at the bottom, the 2 is the real part, and the -25 is the imaginary part. So if it helps you to do this until you get the hang of it and show that it's really 25 times -1, square root the 25, square root the -1, and that gives you 5i. So written in standard form, this is going to be 2 plus 5i. Pretty good? So really all you're doing with negative square roots is you break down the square root normally, but if it's got a negative number underneath, in addition to breaking down the root like normal, you're also going to pull out the letter I. Let's try some examples of adding, subtracting, and multiplying with the letter I, or the imaginary number. So here is my first example. It wants me to add these two imaginary or complex numbers that are written in standard form. Again, when we add complex numbers, all we need to do are essentially add our like terms. So I'm going to add the two real pieces, 4 plus 1. These are like terms. And then I'm going to add the two imaginary. 7 plus -6, and I get 1i, or just I. And you're done. So again, you're treating the I like a variable, and really all we're doing here is combining like terms. Next, same thing on the next one. I'm going to add my two real numbers, the numbers that don't have the letter I. 1 plus 3 is 4. And then I'm going to go back and add my like terms, or my imaginaries. 2 plus -2 is 0. I don't need to put 0i. My answer here is just 4. Now the next one is a subtraction problem. The only tricky part here is just remember you need to either distribute the subtraction sign, or remember you could assume that there's like a 1 here that you could distribute. So I'm going to first just rewrite it and distribute that subtraction sign. So this gives me 3i, and then when I distribute a -1 or the negative sign to a -2, it becomes +2. And then the negative sign to the -3i, same thing on the second, that last set of parentheses, distribute the subtraction sign. Now that I've gotten rid of the parentheses and distributed the subtraction sign, now I'm going to go back and add my like terms. So I'm going to add all my reals first. So I'm going to add 2 minus 2. Oh, my reals are gone, so that's just 0. And now I'm going to go back and add my imaginaries. 3 minus 3 is 0, minus -5i is -5i. And you're done. Next one, same thing. I'm just going to distribute that subtraction sign on this last set of parentheses. So I'm going to rewrite, drop the parentheses. 3 plus 2i plus 4 minus I, distribute the subtraction sign. And now I'm going to go back and add my reals. So I have 3 plus 4 is 7, minus 7 is 0. And then I'm going to go back and get the imaginaries. 2 minus 1i is 1i, minus I is 0. So the final answer here is 0. Next one is a multiplication. All I'm doing is distributive property. So I'm going to distribute the 4 to the -2. That gives me -8. Distribute the 4 to the +3i, and I get 12i. And I'm done. I don't want to try to factor a GCF out, because again, if it says simplify or multiply or add, I don't want to put parentheses back in it. So I'm leaving it like that. The next question is a FOIL question. It's 2 binomials that you're multiplying. So here, I'm going to do the whole FOIL process, or again, you could think of it as distributive property. I like to do FOIL. So first, 2 times 4 is 8. Then outside or outer gives me 6i. The inside gives me -4i. And then finally last gives me -3i squared. Now, if you remember on that very first slide, it told you that every time you ended up with an I squared in your problem, you needed to replace it with a -1. So I'm going to, on the red part, I'm going to take out I squared, and in its place, I'm putting -1. I can also add my outer and inner, just like normal when you FOIL. I can add these like terms, and this gives me 2i. I'm going to rewrite the 8 at the beginning. I now need to multiply the red. -3 times -1 gives me +3. And then now I can add my like terms. I have the 2 reals that I can add. So final answer here is 11 plus 2i. So you're FOILing just like normal. What's different is when you get that I squared, you take it out and put in a -1 in place. And generally there'll be a number in front that you have to multiply to it. Let's try the next one. Again, we're FOILing. Let's go do that. So again, I'm going to do first, 3 times 3 is 9. Outside, 3 times -2i is -6i. inside is positive 6i, and then finally last, positive 2 times negative 2 is negative 4i squared. On this one, the blue and the green cancel out. So I do need to replace the red I squared here with a negative 1. These are now gone, and now I'm left with the 9 in the front. I need to multiply the red. Negative 4 times negative 1 is positive 4. And then I can add my like terms, and the final answer here is 13. Now this is a little preview of the next slide, because the next slide has what is called a complex conjugate. And what that means is when you have exactly the same numbers in your binomial, but one has an addition sign and one's a subtraction sign, these are considered to be complex conjugates. When we have to rationalize, we're going to multiply by the complex conjugate to make the I disappear. Notice when I FOILed these two, my i's disappeared, and I was only left with the real answer. So when you have to rationalize, this is what we're going to do. But we're going to see this on the next slide. Now, if you ever forget and you're multiplying something by its conjugate, complex conjugate, and you forget, you just do the whole FOIL process and your outer and inner will cancel. The next one is a binomial squared. Do not be tempted to just square the 3 and square the 2i. You either memorize the pattern for a binomial squared, or you take the time, write it out 2 times, and FOIL it. If you do not do this, you will miss out on the middle term. So this is why it's important that you FOIL this. So 3 times 3 for first is 9. Outside gives me 6i. Inside gives me 6i. And last gives me 4i squared. Again, we're going to add the blue and the green and replace that red I squared. So replace the red I squared with a negative 4. I'm going to add the middle, and then I'm going to drop down that first term. I now need to multiply the red. So I end up with 9 plus 12i minus 4. Again, add your like terms, these two real ones. 9 minus 4 is 5 plus 12i. Always write the real and then the imaginary. Let me fix that I. All right, last one on the page. Again, all we're doing is FOILing. So first, 2 times 3 is 6. Outside gives me 6i. Inside gives me negative 12i. And then finally, last gives me negative 12i squared. Again, I can add the middle and replace the I squared with negative 1. Add the middle, negative 6i, drop down the 6 at the beginning. Replace here, I get plus 12. Rewrite everything else. I like to rewrite a lot of stuff. 6 minus 6i. Add the reals. Final answer is 18 plus, or no, minus, because it's a negative 6i, minus 6i. Again, don't try to factor out a GCF. We don't want to add parentheses back into something that said simplify. Pretty good. Now we're going to talk about the conjugate, or the complex conjugate. So again, the conjugate, the complex conjugate, is going to have exactly the same numbers but opposite signs. When we multiply something by its conjugate, the I disappears. The shortcut is just to do first and last, because you know outer and inner are going to cancel. So when I do example 10, I'm going to actually do the whole FOIL. But when I do 11, I'll do the shortcut and just do first and last. So again, the conjugate is going to have exactly the same number and the I, but I'm changing the sign that's in between. If it's originally a plus sign, the opposite would be a subtraction. Now I'm going to do the whole FOIL, but as you're going to see, the outer and the inner are going to cancel. So first is 1 times 1, outside, negative I, inside, positive I, and then finally last is negative I squared. The inside and the outside cancel out. So now I'm left with 1 minus, and then I put in the negative 1. So that 1 minus negative 1 really becomes 1 plus 1. So the answer here is 2. Again, remember, when you multiply by the complex conjugate, the I disappears. Okay, this is how we're going to rationalize the denominator. And then 11, I'm actually just going to show you that all you really need to do is first and last. So again, you need to know that the conjugate has the same number and the same letter, but you change the sign. This time it started as subtraction, so your complex conjugate will be an addition sign. So here I'm just going to do first, 4 times 4 is 16. Last, negative 9I squared. Again, you need to replace the I squared with negative 1. I like to rewrite the problem. Negative 9 times negative 1 becomes positive 9. Add 16 plus 9, and my answer is 25. I'm going to do 2 more examples of rationalizing, and then I'll finish the notes on Monday. Pretty good? And we divide with complex numbers, or if you have a fraction, because again, remember, a fraction bar means division. Remember, your denominators must be rationalized, meaning just like before, we can't have a square root in the bottom. Now we can't have the letter I in the bottom of a fraction. So to rationalize, we're going to multiply by the complex conjugate, because remember, multiplying by the complex conjugate makes the I disappear. So let's just try 2 examples for today, and then we'll finish up on Monday. So I need to rationalize number 12. I need to get rid of that I that's in the denominator. And the way that I'll do that is to multiply by its conjugate. And remember, the conjugate, you change the sign. Whatever you do to the denominator, you must also do to the numerator. Because essentially what we're multiplying, that 4 over 1 minus I, really all we're multiplying it by is a 1. Because anything divided by itself is 1. So for the numerator, I just have to distribute the 4. So 4 to the 1 and 4 to the I becomes 4 plus 4I. Shortcut for the denominator, just do first and last. First gives me 1. Last gives me negative I squared. Again, we need to replace I squared with negative 1. So let me rewrite my numerator. I'm going to replace the I squared with negative 1. Don't forget that that subtraction sign is still there, in addition to putting in the negative 1. I can add now the bottom. 1 minus negative 1 gives me 2. Numerator is the same. Now, because I can simplify both the 4 and the 4i by 2, I am going to simplify this fraction. Change these into 2's. So the final answer here is 2 plus 2i. Going to do exactly the same thing to the top. I am going to multiply by the conjugate. So 1 minus I, 1 minus I. This time I need to not just distribute the top, I'm foiling the top. But again, the denominator, you just need to do first and last. So when I do the numerator, let me mark that off. So I'm going to do first, outer, inner, last for the top. So first gives me 1 times 1. Outside gives me negative 1i. Inside gives me negative 1i. But last gives me positive I squared. For the denominator, I'm just going to do first, which is 1, and last, which is negative I squared. I now need to replace both of those red I squareds with negative 1's. Let me rewrite. So 1, and then the blue and the green here do not cancel. These are like terms. This becomes a negative 2i. And then I'm going to replace the I squared with negative 1. Same thing in the denominator. Let me do it in red. So 1 and then minus and then the negative 1. Notice the numerator, 1 minus 1. Those two reals are gone. So in the top, I'm just left with negative 2i. And in the denominator, I get a 2. I can simplify this. And these will both become 1's. So my final answer here is just negative I. So I will finish these notes starting with number 14 on Monday. Again, there is no 5 home. Okay, so on Friday we were working on learning how to rationalize the denominator. So whenever there is an I in the bottom of your fraction, you need to get rid of that I. You need to make it disappear. So in order to make an I disappear, we need to rationalize. So when we're going to rationalize something that's got an addition or a subtraction sign, we're going to multiply by the complex conjugate. And the complex conjugate will have exactly the same numbers, but it'll have an opposite sign. So again, it's always the complex conjugate of the denominator. What we're going to do is multiply the numerator and the denominator by 4 plus 2i. Let's go ahead and fill that in. So 4 plus 2i and 4 plus 2i. Remember, we need to FOIL both the numerator and the denominator. However, remember the shortcut for the denominator, we just need to do first and last. But I'm going to FOIL the entire numerator. So I'm going to do first, 2 times 4 is 8. Outside gives me 4i. Inside gives me 12i. And then last gives me 6i squared. And now I'm going to do the shortcut on the bottom. I'm just going to do first and last. So 4 times 4 is 16. And negative 2i times positive 2i is 4i squared. Now, if you end up forgetting that you can do the shortcut for the denominator, it's okay if you do the whole FOIL because outer and inner will cancel. So now let me go ahead and add the 2 middle. And then I'm going to change all of the I squareds and I'm going to make them all a negative 1. So this will give me 8. Plus 4i plus 12i is 16i, plus 6 times negative 1, I took out the I squared, over 16 minus 4 times negative 1. I'm now going to multiply the negative 1's, so I get 8 plus 16i minus 6 over 16 plus 4. I can add the denominator, get 20, and then I can add or subtract 8 minus 6, get 2, plus 16i. Now I need to reduce this. The 20, I can simplify it with the 2, and I can also simplify it with the 16. Now, on WebAssign, you can leave it like this. Someone in the other class said you can do that. Or you can also pull it apart. And I could make this 1/10 plus 8/10 I, but then I would have to simplify the 8/10 further and make this 4/5 I. So when you're keying it in WebAssign, you can either do this or do this. So you can pull the fractions and give each numerator their own denominator. 15 and 16 are the same thing. I'm going to multiply by the complex conjugate. And again, the complex conjugate is same number and letter here, but it's going to change to a plus sign. And you're going to FOIL that to the top, and you're going to FOIL the bottom. But again, the bottom, all I need to do is the shortcut. So let me FOIL the top. 3 times 5 is 15. Outside gives me 3i. Inside gives me 10i. And last gives me 2i squared. Denominator, first gives me 25. Last gives me I squared, negative I squared. Again, I'm going to add these two, but replace the I squareds with negative ones. So now I have 15 plus 13i plus 2 times negative 1. And then the denominator is 25 minus negative 1. I can multiply this and get 15 plus 13i minus 2 over 25 plus 1. I can add the denominator and then combine the like terms in the top by subtracting. So now I have 13 plus 13i over 26. I can simplify, divide them all by 13, and now I'm left with 1 plus I over 2. And you could also pull it apart and give each the 1 a half, make it a half, and make it I over 2. Let's try 16. Again, I need to get rid of the I in the denominator, so I'm going to multiply by the conjugate. 4 minus 3i, 4 minus 3i. FOIL the top. 4 times 4 is 16. Outer gives me negative 12i, inside 12i, or negative 12i, and last gives me 9i squared. Then I need to do the same thing to the denominator. I'm just going to do the shortcut. 4 times 4, that's first, and last is negative 9i squared. Again, I'm going to add the like terms here, and then replace the I squareds with negative 1. So 16 minus 24i plus 9 times negative 1 over 16 minus 9 times negative 1. I'm going to go ahead and multiply. So 16 minus 24i, and then this becomes negative 9, and then 16 plus 9. I can add the numerator like terms and the denominator, so this becomes 25, and then 16 minus 9 is 7. And that should be a minus 24i. Nothing simplifies here, so you can leave it like this. Or again, remember, you can pull it apart and give it each a 25 denominator. Now we're going to practice breaking down negative square roots. So this is what you're going to need when we do the 1.5b, especially when you're doing the quadratic formula and you end up with a negative under the square root. Let's practice breaking them down. So what we're doing here is we're going to pull out the negative sign by bringing out an I first, and then we'll simplify. So for example, on number 17, if I go ahead and change this into negative 1 times positive 3, and then I can pull out the negative 1 because I know that the square root of negative 1 equals I. So I'm going to change this into I. I can't break down the 3, so it's just I square root of 3. For number 18, again, you can, if you need to see the visual, separate and make it negative 1 times 16. The square root of negative 1 is I. The square root of 16 is 4. Generally, you're going to see it written like a normal variable, so make it 4i. Technically, I4 is the same thing because it's multiplication. However, I would put it in as 4i. For the 48, negative 48, we're going to break it down, make it negative 1 times 48. You can simplify or square root the negative 1. 48 is not a perfect square, so I got to break it down. You can either choose 2 times 24, 3 times 16, 4 times 12, 6 times 8. It doesn't matter. However you're used to breaking down positive perfect or non-perfect squares, that's what we're doing here. I'm going to actually choose to do 16 times 3 because that is going to break down the fastest for me. So I'm going to break this into 16 times 3. I still had that I that I pulled out. So now I have square root of 16 is 4. I can't break down the 3. So final answer here is 4i square root of 3. And again, if you didn't realize 16 was a perfect square, then you could keep breaking it down. 4 times 4, 2 times 2 times 2 times 2, and then make your pairs. Whatever's going to work for you. Let's try the 500. So again, I'm going to break it into negative 1 times 500. I can break this down into an I. I could also break up the 500. 2 and 250. I'm actually going to do 105. So 100 times 5, because again, that's the fastest way to get, because I know 100 is a perfect square. If you didn't realize, you'd break it down. 10 times 10, 2 times 5, 2 times 5, make your pairs. So this will actually come out as a 10. 5 isn't perfect. And then final answer, 10i square root 5. Now 21's a little different because there's a negative sign outside the radical. All that's going to happen here is that negative sign is just going to be in front of the answer at the end. So we'll go ahead and break down the negative 80 into negative 1 times 80. And then I need to break down the 80. You could do 2 and 40, 4 and 20. I'm going to do 5 and 16. Now, if you wanted to just not pull the I out right away, you could just keep bringing down the negative 1 and then just square root everything. So this becomes an I, this becomes a 4, and this stays underneath. So negative 4i radical 5. So notice this negative sign that was out front, it just kept dropping down. And then the final answer is negative 4i square root 5. Now let's practice with some operations where we're going to be multiplying and dividing negative square roots. So let's try number 22. Now on this one, remember when we would break down and we would get down to prime numbers, and once we made a pair, that number that was in the pair came out? I could do the same thing here. I've got a pair of negative 7s. So my answer, if I just do it that way, is negative 7. Don't think of this as a negative times a negative becomes a positive. Again, we need to also, the other way that we would do it is the long way. And I, again, could break this into negative 1 times positive 7, negative 1 times positive 7. This square root's to be an I. This one doesn't break down. Another I, and then a 7. I multiply everything that comes out, so I times I gives me I squared, and then a pair of square root 7s, it comes out as a perfect square. Remember, I squared is negative 1, so negative 1 times 7, same answer I got when I realized I had a pair of negative 7s. And that's how you can do it the long way. Let's do the same thing on number 23. Again, I'm going to break it apart and make it negative 1 times positive 6, negative 1 times positive 10. And now I can either choose to multiply 6 times 10 and then break down the 60, or I can factor right from where it is. It's up to you. So let's say I just decide I'm going to factor the 6 and the 10. I'm not going to multiply it. So these become i's. This can become a square root of 2 and a square root of 3. Square root of 2, square root of 5. I'm at prime, so now I'm going to multiply these two. I get I squared. Multiply, make two pairs here. I got a pair of 2's, so a 2 comes out. The 3 and the 5, they don't pair up, so I multiply them back, and I get square root 15. Remember, I squared is negative 1 times the 2 that came out, and then the root 15. So final answer here is negative 2 square root of 15. Now, if you would have multiplied them, you would have gotten 60, and then either decide 2 times 30, 3 times 20, 4 times 15, and that would have taken you right to where you needed to be. But a lot of times it's just easier to leave them unmultiplied and then just factor the smaller numbers. Let's try 24. So again, I'm going to do the same thing. Negative 1 times 20. Negative 1 times 2. Again, the square root of negative 1 is I. Now, I can either choose to divide 20 by 2 and get square root 10 in the numerator, or, like I've been doing, I could factor the 20 and make it 2 times 10. And now I would look for things to simplify. The i's become 1's, and the same thing with the root 2's. So final answer here is just square root of 10. Again, if you would have rather just simplified this and made this the square root of 1 and this the square root of 10, the square root of 1 is 1. So again, you could have gone right to the square root of 10. Let's try 25. So again, negative 1 times 48 over the square root of 24. So here, if you would rather just divide 24 and 48 and make this a 2, and then square root the -1, make it an I. That'll go right to the answer. Or if instead you like to factor it, so again you could do this, -1, factor the 48 into 24 times 2, and then look for things to cancel. This cancels, and then the -1 square roots to an I, nothing to do with the root 2. So either way. 26. So here what I need to do again, make it -1 times 5, -1 times 15, and then here this becomes an I, this becomes an I. I'm going to factor the 15. You could have multiplied the 5 times 15 and gotten 75 and then break it down. But again, it's, I think, a little bit easier just to factor the way they're given. So again, you have 2 i's here, so I squared. I got a pair of 5's, so a 5 comes out. And then the radical 3 stays underneath. Evaluate the I squared, so it's now -1 times 5 times the square root of 3. So my final answer is -5 square root 3. (27). Again, I can make it -1 times 70. -1 times 7, and this gives me I radical 70, I radical 7. Again, you can choose to just simplify this. 7 goes into 70 10 times. The i's simplify, so the final answer, root 10, or square root of 10. If you'd prefer to factor the 70 and make it 7 times 10 and then get a 7 to cancel, you can do it that way also. Last one of this part. So now we're going to break down -1 times 40. 20 isn't negative, so just leave it. So again, you can factor it.
Pardon interruption at this time.
So for here, either simplify 40 and 20 and make it a square root of 2, or again, you could break down the 40. And then these cancel, become 1's. And then the square root of -1 is I, and then the 2 stays. 29. Now we have more than just one number on top, but it's still the same thing. Now, again, I can do several different things here. Let me go ahead and first take care of the negative signs. So this becomes I square root 12, or let me do it separately. Let's make this -1 times 12. Sorry. So -1 times 12, -1 times 6 over square root of 8. Now, I know I didn't do any where I multiplied before I simplified, so let me just show you that you could also multiply it. So the -1's become i's. I'm going to multiply the 12 and the 6 and get 72. So this both become i's. And then I get the square root of 72 over the square root of 8. But notice I still got to go back and simplify it. Now, if you want to just divide it, 8 goes into 72, square root of 9 times. So now I have negative 1 times the square root of 9, and negative 1 times the square root of 9 is 3. So my final answer here is negative 3. Now, if you did not want to multiply the 12 and the 6, and you would have rather just factored the 12 and the 6, you could do that. You could even break up the factors of 8 and then look for things to cancel. Either way works, but final answer here is just negative 3. Let's try some more. Number 30. Now I'm going to change this to a plus sign. This is a typo. Make that a plus sign. So now, do not be tempted to simplify the 8 and the 4 right now. You need to break down the radical first. So I'm going to get negative 8 plus negative 1 times positive 128. Now I have negative 8 plus I radical 128 over 4. I need to break down the 128. I'm going to actually break it into 2 times 64. So negative 8 plus I square root of 2 times square root of 64 over 4. I can square root the 64 and make it an 8. So now I have negative 8 plus 8i square root 2 over 4. I need to simplify, and I can divide them all by 4. So now my final answer is negative 2 plus 2i square root 2. Let's try the negative 18. We got to break it down. So negative 9 plus negative 1 times positive 18. I need to break down the 18. I'm going to make it 2 times 9. I can square root the 9, make it a 3. So final answer, or not final, but before I simplify, negative 9 plus 3i radical 2 over 3, and now I can simplify. Make it a 1, make it a 3, make it a 1. So final answer, negative 3 plus I square root 2. Try 32, and then we'll do one last topic with I raised to a really big power. Let's try 32. Same thing, break down the negative 50. So 5 plus negative 1 square root 50. I need to break down the square root of 50. I can make it 2 times 25. Square root of 25 is 5. So now I'm left with 5 plus 5i square root of 2 over 10. I need to simplify. Divide them all by 5s. Final answer is 1 plus I radical 2 over 2. So right now, the only fact that we know is that I squared equals negative 1. So my goal here is going to be taking all these higher powers of I, and we're going to break them down and make them all some kind of combination of an I squared. Now, the first example, number 33, is I to the 5th, but it's a little confusing because we're going to have two 2's in it. So let me go ahead and do a different one first. Let me do I to the 9th first. So what we're going to do in order to simplify this is we're going to divide this power by 2. Now, one other thing I want to clarify, that whenever I'm doing any of these higher power of i's, there's only going to be 4 possible answers I could come up with. My final answer is either going to be 1, -1, I, or -I. So if you're doing a question like this on this test or a PSAT or an SAT, and they give you I to the 5,000th power, and you're like, I have no clue how to do this, just pick one of the answers that has one of these 4 choices. You have 25% chance of getting it right. All right, or if it's a free response, fill in one of these, either 1, -1, I, or -I. But let's learn how to do it. So what I do is I take the exponent and I divide it by 2. 2 will go into 9 4 times with 1 remainder. An odd exponent is always going to have 1 left over. So then whatever I get when I divide by 2, that is going to become the power that's on top of the I squared. So it's the power to the power. Because remember, when you raise a power to a power, you multiply. So this is really I to the 8th power, and then we had the 1I that was the remainder that was left over. So I've just changed this problem, I to the 9th, into its an equivalent form. I know that the value of I squared is -1, and then I'm going to raise that to the 4th power. Now the trick here is when -1 is raised to an even number power, and 4 is an even number, the answer will always be 1. If this were an odd exponent here, then the answer would be -1. So when the exponent is odd, it's -1, but when it's an even number, it's positive. Now I also still had this I that was left over. So now 1 times I, and the answer to I to the 9th power is I. Now we can try number 33. Again, what's in the parentheses is always I squared. The number that goes outside of the parentheses is how many times 5 was divided by 2, which was 2. And then you had the 1I left over. Replace I squared with -1. 2 is an even number, so -1 times -1 is +1 times I, and I get I. Let's try the 32. Again, it's always I squared in here, but 32 divided by 2 is 16. Goes in evenly. And now I'll change the I squared to -1. And now -1 raised to an even exponent, and the answer is +1. So again, when that exponent is an even number, the answer is +1. Let's try 33. So again, it's always I squared. 33 divided by 2 is 16. And then I had 1 remainder. Again, we're going to change I squared into -1. -1 raised to an even exponent is +1 times I, and I to the 33rd power, 33 power, is I. 36, this is a negative exponent. Remember, a negative exponent turns it into a fraction. Think reciprocal. So this is going to become 1 over I to the 16th power. I now need to divide 16 by 2, and I get 8. I now can change the I squared into -1. Anything raised to an even exponent is 1, so 1 over 1 is 1. Now, you guys have 2 more examples on your slide, so I'm just going to write them here. Number 37, what is it? I to the -101 or 102? 101? And then 38 is 102? Okay. All right, so let's go ahead and do these. Again, both of them are negative exponents. They both turn into fractions. Again, you're going to divide that exponent by 2. And 2 will go into 101 50 times with 1 left over. 50 is an even number. So -1 to the 50th power gives me +1. So then I get 1 over I. Remember the rule, we can never leave an I in the bottom of a fraction, so I need to rationalize. I'm going to multiply top and bottom by I. And this gives me I over I squared. Remember that I squared is -1. And I divided by -1 is -I. And you're done. Now I got one more example. Again, it's a negative exponent. Make it a fraction. I need to divide the exponent by 2. So this becomes 51. Replace I squared with -1. 51 is an odd number. So this gives me -1. 1 divided by -1 is -1. So that is how you're going to be dealing with I raised to a higher power. Now, for those of you who would like to start the 1.5b instead of the 1.5a, just to give you a preview of what's to come tomorrow, for example, if I said, solve this equation using the quadratic formula, you're going to do it the same way. My a value is 1, b is 2, c is 9. I'm plugging it into the same quadratic formula. So -b plus or minus b squared minus 4 times a times c. That's all under the square root. 2 times 1. And here's what's different. Once I do this, I end up with -32 under the square root. And again, when you did this in 1.4, we would put no solution. But today, we now know how to simplify the square root of -32, and you're going to get an I in your answer. So you're going to be doing the quadratic formula, completing the square, and square root method, and you're going to end up with negative roots, but you got to fix them. So I can fix the -32. Remember, we do -1 times 32 And then I can break 32 into 16 times 2. So then this gives me 4i square root 2. So now I have negative 2 plus or minus 4i square root 2 over 2. And then you just simplify. Change these to 1s and change this to a 2. So negative 1 plus or minus 2i radical 2. So that's the only thing different when you go to do the 1.5b. That was one of the examples for tomorrow. So now I only have to do 7 tomorrow, and it should be pretty quick. Whatever time remains, you'll be able to work on your WebAssign, and if you get stuck on anything, you can ask me. There is a test review already posted. You can start working on that. And then that's what we're going to be doing on Wednesday after we go over any homework problems. Any questions?
Miss Warren,